Indiana University manages 20 different research and education networks around the country and around the globe. We've been involved with running networks for nearly 15 years. So we manage research and education networks at a large scale, very sophisticated networks, advanced networks. We've recently got involved with software-defined networking with the Genie project from the NSF, and really pushing the boundaries of where networking is going and really developing the next generation, not just of networks, but of network engineers and network developers. Well, software-defined networking is really an umbrella to describe the ability to program a network and to have an abstraction layer on which you can program that network. And OpenFlow is really a piece of that allows you to program the network hardware that's in your network today. On top of that, you build a whole set of software on which those applications can interact with that software to control the network. So just recently we announced that we built a network called the Monon 100. That's a 100 gigabit network that runs between Indianapolis and Chicago. And the switching fabric for that is based on the Brocade MLX. And so we're also working with Brocade on an OpenFlow implementation that will then allow us to program that hardware and customize it to the unique feature set for our network. Well, I think Brocade is taking the approach of a sort of an open ecosystem where they support OpenFlow, and then you can build your own implementations on top of that. So I think the key here is high performance, 100 gigabit, 10 gigabit, as well as the openness and the open ecosystem platform. So as we look at our network of the future, we're looking 2, 3, 5 years out. We see SDN being a critical component of that, really taking both creating a platform where we can uniquely customize and third parties can customize a network to our specific needs, but also the ability to virtualize our network and manage our network in a way that is really a lot like where the hyperscale data centers are going, but on a large enterprise. This idea of building a fabric and then creating virtualized networks on top of that, where we can have a high-performance network with a high degree of control over the network from a central location in a way that's greatly simplified from the way we manage networks today. So one of the keys of the Monon 100 network is that we're building 100 gigabit that connects us to the national networks in Chicago. And we really are using that 100 gigabit to support big data science, things like the Large Hadron Collider that are generating multiple terabytes of data. And with the MLX, we have 100 gigabit and OpenFlow, and we can use OpenFlow to provision that network to provide dedicated bandwidth for those big science applications.